I forgot to start recording. Okay, so it's the 18th of September. I almost said December. That would be crazy. 18th of September, and we're going to start to talk a little bit today about measurement. And this sets you up well for your lab tomorrow. So, you also watched a video and took a quiz for me. And I realized I probably should have delayed that video and quiz. But the goal of those intro videos was to take some of the parts that I have found to be stumbling blocks for students in the past and try to front load them. And I will say chapter 2 is not a hard chapter. It's not hard at all. But in the past I have realized that students really struggle with it. And I had a former student say, you know, of the whole front loading videos thing, he said, oh, anything that would help. And he was a really smart kid who got A's on most things in chemistry, but still struggled with chapter 2. I don't know why. So I keep trying new strategies to make this work better. Chemistry is all about measurement. It's about observation, it's about measurement. You've done measurement already in your first 2 labs. It's both qualitative and quantitative. What does qualitative mean? Do you know? Gesundheit. Don't know what's going on out there. Qualitative means descriptive. So if I make a set of observations about this bag that are qualitative, I could say, well, the bag appears to contain a dark brown substance interspersed with smaller objects. The bottoms of those objects are dark, and then there's a little flaggy looking thing on them. That's not real good scientific language, but it'll do for today. If I wanted to make quantitative measurements, what are those? Do you know? Numbers. All numeric. So I could talk about the mass of the bag. The bag has a mass of, I'm just guessing off the top of my head, 436.25 grams. I have no idea what what's the mass. The bag has a volume of blah, blah, blah. The material in the bag has a melting point of. That's quantitative measurement. We use both in chemistry. And when you're doing labs, when you're taking observations, you are very often asked to make both qualitative and quantitative observations. The substance in the test tube turned blue. It's qualitative. That is qualitative. We brought the water bath to 100 degrees Celsius, meaning it boiled, and held it there for 60 seconds. That is all qualitative, or quantitative. My goodness, sorry. When we make measurements, and now we're talking about the quantitative, they represent quantities. Quantitative quantities. So a liter is a unit of measurement, but the quantity that it measures is volume. And that's a really subtle, weird distinction, but it's useful. In science, and you know this, you probably knew this coming in, and the video should have kind of helped with that. We use the SI system. A little bit different than metric. All SI units are metric, but not all metric units are SI. So we'll look at the 7 base units in a little while. There are 7 bases, and then there are a whole ton of derived units. In here we will use extensively the derived units for volume, and we'll use the derived units for density, which are not SI, they're derived, but they're combinations of other units. These are the 4 SI units that we'll use the most in here. There are 7, but there are a lot of them we just don't use. So we use mass a lot, though we do not typically use the actual official SI unit. The official, this is weird. This is weird and everybody forgets about it. The official SI unit for mass is the kilogram. What do we usually measure in? Grams. And when we're doing stoichiometry later, we have to measure in grams because the math doesn't work if you don't. Yet, the SI unit for mass is the kilogram. It's bizarre. I don't know why. They didn't ask me. For length, it's the meter, though very often we're using smaller amounts of materials that would make it more sensible to measure in centimeters. For temperature, it is Kelvin. Nobody measures temperature in Kelvin, but if you did, you might get to say something like, whew, you better wear sandals today. It's going to be 200 and, what is it out there today? This morning, probably about 293. It's going to be 293 degrees out there in Kelvin. Which is only about 27 Celsius, which is somewhere in the 80s in Fahrenheit, the scale that we're all familiar with. So if you want to mess with your friends and family, you can learn to do Kelvin conversions in your head and give them the day's forecast in your head. You better grab a jacket. It's going to be 270 today. That's okay. See, this is how I entertain myself. The other one that we'll use extensively starting in a couple of weeks and then continuing through the end of the year is the mole. That's for amount of a substance. And mole is kind of like a dozen. It's just a number of things. Now, what I love is, kilogram gets abbreviated kg, meter gets abbreviated m, Kelvin is K, mole, and this is a quote from Mr. Voorhees, wow, that was nice, they saved you one letter. The abbreviation for the mole is MOL. Yes, they saved you one letter. However, you can't shortcut that because ML means something else and M means something else. So you do actually have to use MOL, as silly as it seems. If you want to see the other 7 units, page 34 in your chemistry text has got them all. Okay, these are the derived units, and you'll be using derived units in your lab tomorrow. You'll be using derived units for, you already read the lab, right? Which derived units? You know yet? Density. So you'll be using grams per cubic centimeter. So we can take any SI units and combine them in sensible ways to form derived units. So for velocity in physics, we typically measure in meters per second, acceleration in meters per second squared. In chemistry, we do a lot of density measurement and volume measurement. And density is equal to the mass per unit volume. Density equals mass per unit volume. We use density measurements a lot to ID substances we're not familiar with because densities are intensive properties, intensive characteristics of materials, so they're useful for doing identifications. The most common measurement for density is kilograms per cubic meter, though tomorrow you'll be doing grams per cubic centimeter. The density of water is 1, and so it's a nice benchmark. We can compare things as being more or less dense than water. Again, page 38 in your chem text has a complete list, or a more complete list, I should say, of derived units that are used in chemistry. But the most common ones are volume and either cubic meters or cubic centimeters, and density is big. Density is a really important unit. Oops. We're going to talk about conversions, and we're going to use conversion factors. Who here feels 100% confident in their ability to do metric conversions? Okay, quickly and accurately. Okay, that's fine. I have some tricks that I've developed over the years that I think make the process a lot easier and less prone to errors. I think there are a bunch of ways to do it. I'll tell you that. There are a bunch of ways to do metric conversions. I will actually say my way is better. I'm fine with saying that because my way avoids some of the common pitfalls. So what we use to do conversions are conversion factors. And conversion factors are based on the idea that you can multiply anything by 1 as often as you want, and it remains unchanged. 7 times 1 times 1 times 1 times 1 times 1 times 1 is still 7. So as long as we're multiplying something by something that means the same thing top and bottom, we're really multiplying by 1. So if I'll use my example of 7. And I am multiplying, so this is 7 days. And we will be using factor labels. This is the start of your extensive use of factor labels in chemistry. Well, 7 days. I want to know how many years that is. Is that some fraction of a year? Yeah, it is. So, is it true that 365 days equals 1 year? Yeah. If these two things are equal, I am in actuality multiplying by 1. I'm changing the units, but I'm in actuality multiplying by 1 because these things are equal to one another. That's the thing you always have to keep your eye on when you're doing conversions. Okay, so on page, and yeah, if you need to borrow a textbook, please grab one. And if there are other people at your table who need one and you're nice enough to get one for them, boy, aren't you a peach. This is what you have on page 35. And if you like having that image available on your iPad, take a shot of it and save it in your photos. This is a table that lists all the metric prefixes that are used with their unit abbreviation and their exponential factor. You're not in middle school anymore. You're not freshmen anymore. You're going on to higher sciences. You're not going to write 100 centimeters in a meter anymore. Okay? You're going to use those exponential factors, which is why we talked about calculations using scientific notation first. It seems awkward at first, but it will make your life so much easier in the long run. I'm a big believer. I don't do things for no reason. I don't do things to keep you busy. I do them because they work, and this works. But you have to get used to doing it this way. The ones that I want you to know without thinking about or looking up: mega, kilo, centi, milli, micro, nano, pico. Okay? So I won't give you a specific quiz on those. I think that's silly. I'm just going to ask that you use them. And I'm going to give you enough opportunities to practice using them that you end up memorizing them anyway. While you're getting to that point, you'll look them up. And that's why it's a great idea to just take a snapshot of this. Know their abbreviations, know their exponential power. Okay? So and those are the ones that I expect you to be responsible for on the test. If I give you a conversion using any of those, I expect that you'll know them. So let's go ahead and practice our first one. Let's practice a couple together. Then I'm going to hand you a practice sheet, and I'm going to let you work while I circulate and see how you're doing. And the answers are up right now. The key is not, but I'll get the key up in a second. Okay, now some of these are really stupid, like who wants to convert kilometers to millimeters? Kilometers in countries, which is every country in the world except us that use the metric system in everyday life. Kilometers are what you would see road signs in. It's 10 kilometers to Rogers from here, roughly. Okay? Who on earth wants to know how many millimeters that is? No one. It's like asking how many inches is it to Cleveland. It's a stupid question. But it's good practice. So I'm just admitting right up front that this is dumb in terms of an actual real-world example. We'll get to better ones, I promise you. So you're given, and you're looking to convert to millimeters. You're going to do, how many of you have done factor labels before? Physical science? No? Nobody did a factor label? Factor labels are the things that look like this, and you multiply across the top, multiply across the bottom, and divide? No? Okay. Well, we're gonna get you into factor labels, because factor labels are really the most common kind of math that you will do in chemistry. We will use them all year long, and you will use them in college chemistry. So our first step in doing any factor label is setting up the first box, and the first box is always going to contain your given with the number and the units. So I'm going to put 426 kilometers in that first box. I'm going to draw my line. And this is going to be a one-step. No, this is going to be a two-stepper. So I'm going to leave myself room to do that. Now, when you're doing factor labels, it's all based on units canceling out. Okay? So always in the next box on the bottom, the units here are going to match the units there. Okay, it's this nice little symmetry thing. So units down and next box are always going to match so that they'll cancel in the end. Here's part of the thing that's my shtick. Always go through the base unit. How many of you at some point in your school lives were taught to convert by counting differences and moving decimal places? No? Yes? No? I'd be thrilled if none of you ever learned that technique, because that means I don't have to like beat it out of you with a chemistry stick, because it doesn't always work. It's too prone to mistakes, and I make them myself. This is very, very, it's idiot-proof. And I make really idiotic mistakes typically, so I like methods that are relatively idiot-proof. Which means I'm going to go into meters. I'm going to go into meters. So if we think about all of our mega, kilo, meter, gram, liter, those are our base units, the things that have no prefixes on them, okay? And then centi, milli, micro, nano, pico, okay? This is the base unit. When you're doing conversions, you always go through the base, okay? So you're converting to base and then going on. Even if you're staying in larger prefixes or smaller prefixes, it avoids mistakes. Okay, I'll get rid of this now. So what we need to put in here for numbers is the exponential relationship between kilo, meters, and meters. And that's where you're going to go back to this chart, and you're going to look at kilo. And a kilometer is 10 to the third meters. 1 kilometer is 10 to the third meters. The power of 10 always goes with the base unit. The power of 10 always goes with the base unit. This avoids the whole, well, where does it go? Well, I don't know if you do it this way. The power of 10 that is listed and given in your book in that table always goes with the base unit. Where does the power of 10 go? With the base unit. Power of 10 goes with, which one does it go with? The base unit. Just it's nice because again it's idiot proof. You don't have to think too much about where it goes. The power of 10 goes with the base unit, period. And I generally try to stick a 1 in next to the prefixed unit as fast as I can so I don't do something stupid in the meantime. Because I'm prone to that sort of thing. Okay, well now if I stopped right there I'd be in meters. But I don't want to be in meters, I want to be in millimeters. So again, this unit has to go down to cancel. So I'm going to put meters there. Those have to match so that they will cancel out. I've got meters there. I want to end up in millimeters. And now if I look at how my units would cancel, kilometers cancel, meters cancel, I'm left with millimeters. And that's what I want to be in. So I'm good. What's the relationship between millimeters and meters? Let's go back to here. Let's look it up. 10 to the negative third. So 1 millimeter is 10 to the negative third meters. Exponent always goes with the base unit. So let me get rid of some of the extraneous stuff here. Cut that, cut that, cut that. I'm left with a problem that I can solve pretty easily. Now, in terms of avoiding mistakes, I screw up moving the decimal to get into proper scientific notation all the time. It's one of the things I have to think hardest about. So I developed a technique to not allow myself to make that dumb mistake, and that's to just convert whatever I'm using into scientific notation to start with. Then that's done, and I'm just doing the exponents. So this becomes 4.26 times 10 to the second kilometers. And now all I have to do is 4.26 times 10 to the 2 plus 3 minus negative 3. 2 plus 3 minus negative 3. So what does that give me? 4.26 times 10 to the 5 plus 3 times 10 to the 8th millimeters. 4.26 times 10 to the 8th millimeters. I do expect you to show this. Like I said, you become big fancy rock stars, fine, don't show it anymore. But for right now, I want you to show it. I'll tell you one thing. It also helps me on your tests, give you partial credit. If I see that, oh, look at that. You put that in as a positive 3. Oh, she accidentally added instead of subtracted. I can do partial credit. If you just magically have a wrong answer, I can't give you any partial credit. So it helps me give you points whenever there's doubt. And I look for opportunities on tests. I look for opportunities to give partial credit. So help me help you by putting down the details. Okay, do you want to do one more together? Okay. This symbol here is called mu. It's a Greek letter. It looks like a U, the front leg of which got extended. And one of my dear former students many years ago drew the angry physics cat saying, meow, which I think is hilarious. And if you want to draw me any science cartoons, I will add them to the wall of famous former student science cartoons. Okay. So, I am going from, whoops, let me get rid of all this junk. I'm going from micrometers to millimeters. And yet I am still going to go through the base unit because it prevents me screwing things up. I like things that prevent me screwing things up. So I'm going to set it up. What goes in the first box? What is it? The given. Yeah, the given. So 91.8 micrometers. What units go in the next box down below to cancel? Micrometers, same units. What units are going to go above that? We're always going through what? Base. I'm going to buy you guys some coffee, I think. Okay, I'm going to stick my 1 in there. What's the relationship between micrometers and meters? 10 to the negative 6th. Where does that exponent go? With the base. Always with the base. Always with the base. Always with the base. You can make your own Meghan Trainor lyrics to the new metric conversion song. I know you want to. Always with the base. Never mind. Oh, you people. Okay, what units are going to go in the bottom in that last box? Matt. What units are going to go in the bottom in the last box? Meters. And then what's going to go on the top in the last box, Eddie? Millimeters, the thing I'm trying to get into. Okay, I'm going to stick a 1 in front of millimeters before I do something stupid. What's my exponential value for millimeters? 10 to the negative 3rd. Okay, there's one thing that I still want to do to prevent me screwing up and doing dumb stuff. I'm going to convert this to scientific notation. So that becomes 9.18 times 10 to the 1st. I only move the decimal 1, it's 10 to the 1st. So now I have 9.18 times 10 to the 1 plus negative 6 minus negative 3. So negative 5, 1 plus negative 6 is negative 5, plus 3, negative 2. So my final answer (9.18 times 10 to the negative 2nd millimeters). And it's not complete until you have the units. 9.18 times 10 to the negative 2nd millimeters. Questions? Concerns? You want me to cut you loose to work on practice?